Welcome my students. You all are welcome in 12th Physics Board Special. Today we discuss about atomic physics. Atomic physics contain few theoretical part and some conceptual and numerical part. Atomic physics is in fact start from the nature of the atom and properties of the atom. First of all, we discuss about the discovery of atom. What does it mean by atom? Atom is a smallest building particle of matter which cannot be further divided. It was earlier discovered by scientist John Dalton. According to John Dalton, it cannot be further divided. But this theory failed because atom can be divided by the recent next theories. Then after that, J.J. Thomson was there who gave first model of atom. According to J.J. Thomson, atom is a small spherical region of radius 10 to the power minus 10 meter, that is of order of angstrom. The atom is a spherical region in which positive charge is uniformly distributed while negative charge remain at certain places. This is all about the positive charges which are uniformly distributed and negative charges exist at particular places. The negative charges will lie in this way, this way, this way, this way. Atom is electrically neutral. That is, net charge of atom is 0. That is, net Q will be 0. It means the amount of positive and negative charge always remain same. He discovered electron from his theory. In support of his theory, he gave plum pudding model in which pudding is a sweet dish. This is a sweet dish in which positive charge is supposed to be this sweet dish and the negative charges were the fruits called plums which were used for the decoration. These were supposed to be negative charges. We can say in this way negative, 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 negative. This can be explained on the basis of watermelon model. In watermelon model, you can take the edible portion as positive charge and the location of seeds as negative charge. This was the first model. The two things which are essential which he gave, and these are atom is electrically neutral and he has discovered electron from his theory or his model. This is all about the Thomson's atomic model. After this discovery, there was another scientist whose name was Rutherford. Rutherford discovered nucleus from his experiment. According to Rutherford, nucleus is in fact a rigid positive charge lying at the center of atom. In support of his theory, he conducted an experiment, that is Rutherford's alpha particle scattering experiment. It is also known as gold foil experiment. Now, what is gold foil experiment? Listen, he took a foil which is very thin. Its size is of order of 10 to the power minus 8 centimeter, which is of order of atom. Then he took a source of alpha particle which can be a radioactive element which can emit alpha particles. These alpha particles are emitted from this element continuously. These are allowed to bombard on gold foil. It is observed that most of the alpha particle passed straight without deviation. Very few of them will get deviated by acute angle. Very few of them will get deviated by obtuse angle, and out of 10,000, one alpha particle retrace its path by 180 degree, and from this he conclude that atom has a rigid positive charge at the center which is called nucleus. We can explain in this way: atom can be supposed to be a spherical part. A rigid positive charge can be at center which is nucleus. This alpha particles which were passed straight without deviation were far away. When alpha particles become close to the nucleus, these will get deviated either by acute angle or by obtuse angle. Out of 10,000, one alpha particle retrace its path, which proves that at the center of atom there is a rigid positive charge called nucleus. By this theory, he discovered radius of nucleus, and this radius of nucleus was found to be 10 to the power minus 15 meter of order of 1 femtometer or 1 Fermi. This is the conclusion of alpha particle scattering experiment or gold foil experiment. These alpha particles were counted by scintillation counter or by zinc sulfide screen. Now listen, how we can find the radius of the nucleus. For this purpose, we have to take two concepts. One is the energy of alpha particle, which is kinetic energy. Other is the balance of this kinetic energy, which is potential energy between alpha particle and nucleus. This is a nucleus, this is positive charge. Alpha particle was coming straight and then rebounded. This separation is R. Here kinetic energy of alpha particle E alpha should be balanced by the concept of potential energy in between them, and potential energy is 1 upon 4 pi epsilon naught 2 Ze square upon R. Now the question arises, why we have taken 2 Ze? Because charge of alpha particle is 2 times charge of proton, that is 2e we can take, and the charge of nucleus, that is Ze, we can take. By using this formula we can find radius of nucleus 2 Ze square upon 4 pi epsilon naught E alpha. By solving this we will have 10 to the power minus 15 meter of order of the radius of nucleus, which is of order of Fermi. This is about the alpha particle scattering experiment. Students, now we shall discuss about the drawbacks of this theory. This theory shows that alpha particle, when strike and rebound, then this is a small spherical region which capture all the electrons around the circular part, and he told that these electrons will lose energy continuously. Now, how these will lose energy continuously? For this purpose, he told that whenever these will move, these have a condition, and that condition is the centripetal force must be equal to electrostatic force. Then these will lose energy. He will not give any explanation about that. He just told that these will lose energy, electrons will lose energy. Now, this is the basic drawback, or you can say this is the basic wrong thing he has told. If any electron which is revolving around nucleus is continuously losing energy, then it will acquire a spiral path and finally it will fall into the nucleus. Then atom become unstable. So he was failed to explain stability of atom. This was the first thing. Now what about the second thing? Second thing is he was failed to explain spectrum of atom. He told that it is losing energy continuously, then spectrum should be continuous. But in fact, spectrum is not continuous, it is line spectrum. So this was the another failure of Rutherford's atomic theory. Now, what about the third atomic theory? That is Bohr's atomic theory. Bohr also gave his atomic model, and in support of his atomic model, he gave 3 postulates. What were these postulates? Listen. According to Bohr's first postulate, an electron revolving around nucleus will have necessary centripetal force, which is balanced by the electrostatic force between nucleus Z and electron if orbital radius is supposed to be r. Then its result will be mv square upon r, that is centripetal force, should be balanced by 1 upon 4 pi epsilon naught Ze square upon r square. This is first Bohr's postulate, you can say first Bohr's postulate. Now, what about the second postulate? According to second postulate, he told that the electron which is revolving around nucleus will lie in those orbits or energy level whose angular momentum is integral multiple of h upon 2 pi. That is, mvr should be equal to nh upon 2 pi. This postulate was given on the basis of Planck's quantum theory. Now what about the third postulate? According to Bohr's third postulate, he told that electron which is revolving around nucleus will not lose energy continuously. It will lose energy when it will jump or transit from higher energy level to lower energy level, and that is, according to third postulate, En2 minus En1 is equal to E, and that E will be h nu or hc upon lambda. This postulate were given on the basis of Maxwell's wave theory or Maxwell's electromagnetic wave theory. Now, these are the three postulates. By using these postulates, you can find the orbital radius, you can find the orbital velocity, you can find the energy, you can find the wavelength of photon emitted when transition takes place. Now we shall discuss about the drawbacks of Bohr's atomic theory. First drawback, it is true only for the atoms having one electron, that is only for hydrogen atom. Second drawback is, according to this theory, we cannot explain about the orbital motion. According to this theory, the circular orbits are there, but Sommerfeld proved that the orbits are elliptical. The third drawback. Third is, this theory cannot explain the stability of nucleus. Fourth is, this theory takes the quantization, which is quantization of orbitals by Planck's theory, but it does not explain about that, and no proper explanation was given. The fourth is, he has taken Maxwell's electromagnetic theory and Planck's quantum theory together, which is impossible. You cannot take India and Pakistan together. So this is absolutely false. And then the next drawback was, this theory is not sufficient to explain Zeemann's effect, which is splitting of spectral lines in the presence of magnetic field. This theory also failed to explain Stark's effect, which is splitting of spectral lines in the presence of electric field. This theory fails to explain the microstructure and the intensity of spectral lines. So these were several failures on the basis this theory is not completely true. But this theory is very helpful in determination of orbital radius, orbital velocity and energy. Let us discuss about determination of orbital radius. Now, orbital radius, R, which is electron orbiting around nucleus. How to find? For this purpose, we have to take two postulates. First is mv square upon r is equal to 1 upon 4 pi epsilon naught ze square upon r square, and the second is mvr is equal to nh upon 2 pi. This is equation first, this is equation second. You can eliminate one quantity which is not required, that is velocity, to find orbital radius. How to eliminate? For this purpose, you have to take out v from here, that is nh upon 2 pi mr, and this value is placed in equation number first. Now, how to put? When you put this value, you will have m into n square h square upon 4 pi square m square r square upon small r is equal to 1 upon 4 pi epsilon naught ze square upon r square. You will find few quantities will get cancelled and you will have the result, that is radius r, and this radius r is found to be 0.529 n square upon z in angstrom. This result is in fact Rn is equal to 0.529 n square upon z angstrom. This result shows that radius is directly proportional to n square. Radius is inversely proportional to atomic number z. That means for different orbits of increasing order, the radius will increase, and different order of increasing atomic number, radius will decrease. Now we shall discuss about the orbital velocity. What about the orbital velocity? For this purpose, we have to find two postulates again. First postulate is mv square upon r is equal to 1 upon 4 pi epsilon naught ze square upon r square. Second postulate again mvr is equal to nh upon 2 pi. Let us divide them to get the value of orbital velocity. First divided by second. You will have orbital velocity Vn is equal to 2.19 into 10 to the power 6 Z upon n meter per second. This indicates that with the increasing order of the orbits, velocity go on decreasing, and increasing order of atomic number, velocity go on increasing. That is Vn proportional Z, Vn proportional 1 upon n. This is all about the orbital velocity. Now we shall discuss about the energy. What about energy? The energy will be kinetic energy as well as potential energy. This is total energy and it is found to be minus 13.6 upon n square into z square electron volt. It is measured in electron volt. Now, different values of energies you have to learn. E1 minus 13.6 electron volt, E2 minus 3.4 electron volt. We are just putting the value of n, nothing else. E3 minus 1.51 electron volt, E4 minus 0.85 electron volt, E5 that is minus 0.54 electron volt. These are the few values which are essential for this determination. These are very helpful whenever an electron is transiting from one energy level to another energy level and we have to find the energy emitted. This is all about the energies. These are the application. Now, when electron jump from one energy level to another energy level, what happen? Whenever electron will jump from higher energy state to lower energy state, then according to third postulate, the photon will be emitted which is having particular frequency and particular wavelength. For this purpose, a formula of wavelength is given and that is 1 upon lambda is equal to R 1 upon n1 square minus 1 upon n2 square. These are energy states. N1 is first and N2 is second energy state. Now what about the wave number and what about the frequency? If you have to find the frequency, that is nu is equal to C upon lambda, then frequency will be C R 1 upon n1 square minus 1 upon n2 square. This is frequency of photon which is going to be emitted. Now what about the wave number? Wave number is always reciprocal of wavelength. This is in fact reciprocal of wavelength, inverse of wavelength. It shows the number of waves which are captured or which are obtained from transition. Now the question arises how the spectral lines are obtained. Spectral lines are of several types. These are categorized in 5 basic parts in physics and these are in the form of series: Lyman series, Palmer series, Parsons series, bracket series and Pfund series. These are on the basis of energy levels which were given. Now listen, these are few energy levels: first, second, third, fourth, fifth, sixth, seventh. On the basis of energies, this is E1, this is E2, this is E3, this is E4, this is E5, this is E6 and this is E7. It is n is equal to 1, it is n is equal to 2, it is n is equal to 3, it is n is equal to 4, it is n is equal to 5, it is n is equal to 6, it is n is equal to 7. When electron will jump or transit from the upper energy state to first, that is from 2 to 1, from 3 to 1, from 4 to 1, from 5 to 1, from 6 to 1, from 7 to 1, then it is known as Lyman series. Then after that, when electron will transit from 3rd, 4th, 5th, 6th, 7 to energy level 2nd, then it is Balmer series, it is Balmer series. Then when jump in the 3rd from the upper state, it will be Paschen. Then it is jumping from 5th, 6th, 7th to 4th, then it will be bracket. And when it is going to jump in 5th, from 6th, 7th, etc., then it will be Pfund series. These are few important series. Now, what about wavelength in these cases? The wavelength will be 1 upon lambda is equal to R 1 upon N1 square minus 1 upon N2 square. These wavelengths will exist in a particular spectrum. Now, we shall discuss about Lyman. This will exist in ultraviolet region. Remember students, it is very important. Balmer series, it will exist in a particular spectrum, and that is visible spectrum. Now what about these three? These all three will exist in infrared region. So the question can be on the basis of Lyman, Balmer or Paschen bracket, etc. Balmer series always exists in visible region. Lyman series always exists in ultraviolet region. Balmer series always exists in visible region, and remaining all three will exist in infrared region. This is all about the series. Now how to find the wavelength and what about the numericals based on that? If you have given that electron is transiting from 3rd energy state to 1st energy state, which will be the series? The series will be Lyman. Very simple. Now, what about the wavelength in this case? So, wavelength will be 1 upon lambda is equal to R 1 upon N1 square minus 1 upon N2 square. R is Rydberg's constant. Its value is 1.097 into 10 to the power 7. It is transiting from 3rd, that is N2 is 3rd. It is transiting to 1st, that is N1 is 1st. Then 1 upon lambda is equal to R into 1 upon 1 minus 1 upon 9. Square of 3, that is taken to be 9, and 1.097 into 10 to the power 7 into, take its LCM, it will be 8 upon 9. By solving this, you will get the value of wavelength lambda you can achieve. This is all about the numerical problem based on that. Region is important. Remember, visible region, there are 7 different colors, and these colors can be occupied depending upon their wavelength. Now, the logical question. In this part, whenever you are moving from first series to last series, the wavelength will increase, and whenever you are moving from first line to last line, wavelength will decrease. For example, if someone is moving from first line of Lyman to last line of Lyman, then obviously wavelength will decrease. Whenever one is moving from first line of Pfund to last line of Pfund, the wavelength will always decrease. But whenever you are moving from Lyman to Pfund, then wavelength will increase. This is the concept. It is very, very important for a particular spectral lines. So this is about such kind of numericals. Now, what about the ratio of radii in different energy levels? This is the another kind of question, and that is R1 is to R2 is to R3, that is 1 square is to 2 square is to 3 square dash dash dash, that is 1 is to 4 is to 9. This is the orbital radius. What about the ratio of orbital velocity in different cases? Then V1 is to V2 is to V3, and that will be 1 upon 1 is to 1 upon 2 is to 1 upon 3. How we can solve these questions? On the basis of formulas R proportional n square and V proportional 1 upon n. Now, another question. Another question about the energy transmission or energy level transmission. So if any electron is jumping from third energy state to second energy state, then what about the energy difference? That will be E should be equal to E3 minus E2. You can put the value of E3, that is very well known, that is 1.51, and you can put the value of E2, and that is minus 3.4 electron volt. By simplification, you get its answer, that what about the energy obtained. Now, another part of this atomic physics is, what is excitation? What is ionization? Let us discuss about excitation. Excitation energy and excitation potential. Whenever electron is going to jump from higher energy state to lower energy state, then it requires a particular excitation. Excitation means whenever you have to transit an electron from particular energy state to another energy state, then this energy required is excitation energy, and the potential so required is excitation potential. Listen, excitation energy is E excitation is equal to En2 minus En1. N2 refer for any upper energy state, N1 refer for any lower energy state. Excitation potential you can obtain by E excitation upon E, that is E is charge of potential. It is measured in volt, while excitation energy is measured in electron volt. This is about excitation. Now what about ionization? As you know, ionization means whenever electron is required to eject out from a particular energy level. For this purpose, very simple energy required to take out electron from particular energy level, and this is known as excitation energy, and excitation potential is required potential for that purpose. Excitation energy is E excitation is equal to minus En electron volt, while excitation potential is excitation energy divided by E, it is measured in volt. This is all about the excitation energy and excitation potential. Ionization energy is E ionization is equal to En taken in negative electron volt, and ionization potential is E ionization divided by E measured in volt. What about the numerical problem on this? If you have to take out electron, you have to ionize electron from fourth energy state, then ionization energy will be minus of minus E4 electron volt, and that will be positive, and E4 is 0.85 electron volt. This is the energy required for ionization from fourth energy state. Now, what about the ionization potential in this case? V ionization, as you know, that it is taken by E ionization upon E. So, just remove electron, you will get 0.85 volt. It is very important, and it is taken in several calculations. Now, what about excitation? Numerical based upon excitation. Find out the excitation energy and excitation potential when electron will jump out from fourth to second energy state. Then excitation energy E excitation will be E from fourth to second. So E4 minus E2 taken in negative. Now what about E4? As I have told you earlier, 0.85 electron volt. And what about E2? That is minus 3.4 electron volt. By solving this, you will get excitation energy, and by removing electron, you will get excitation potential. V excitation is equal to the quantity this obtained in measured in volt. This is all about the numerical based problems. Now, what about the logical questions? We shall discuss about few logical questions based upon several theories and several concepts. The first concept is, what is the basic drawback of Thomson's atomic theory? In this theory, he told that positive charge is uniformly distributed, It is impossible. Positive charge remained at center, which was later derived from Rutherford's experiment. So this was the basic drawback. Now, what about the consequence of Rutherford atomic theory? The consequence is discovery of nucleus, which is lying at the center. Now, what about the quantum numbers? Quantum numbers were told by Sommerfield's atomic theory. Now, the question arises that what is the quantization of orbital and what is its principle? Quantization of orbital were given on the basis of Planck's quantum theory, and its principle is according to the angular momentum, which is integral multiple of h upon 2 pi. This is all about the atomic physics. So please students, just get the benefit. It should be applied for the different benefits of the physics. Quick revision for the board examination, and do subscribe, do like, and do share my channel.